New project. New project.
Hello guys, how's our project?
Okay, boss.
Very good.
Really? It is challenging.
It's so easy, boss.
Alright, then explain.
Okay, so let me start with my part first.
Food processing plants use a large amount of water for cleaning and cooling. Without reuse, all wastewater is discharged, increasing operating costs and environmental impact.
In a modern fish processing plant, large volumes of water are essential for daily operations. But what happens to this water after it's used? From production to cleaning, water becomes wastewater, which must be treated before it can be safely reused or discharged. The journey begins as all wastewater is collected in a central tank, the first step in a sophisticated treatment process. First, in the primary stage, large solids are physically removed through a simple filtration process, protecting the system downstream. Next, in the biological treatment tank, naturally occurring microorganisms are used to biodegrade and significantly reduce organic pollutants. To further polish the water, it undergoes sand filtration for fine particle removal, followed by activated carbon filtration to enhance clarity and remove any remaining odors. The result is high-quality reclaimed water, safely stored and ready for its next purpose within the facility. This treated water is now reused for non-product contact applications like floor cleaning, cooling tower makeup, and toilet flushing, closing the loop and promoting sustainability. This complete wastewater treatment and reuse system demonstrates a commitment to environmental responsibility and efficient resource management.
Wow, I love your idea. So we're in the meeting now. Thank you.
Thank you, boss.
First, let's look at our capital expenditure. Our total setup cost for processing equipment is 13,831 ringgit 90 cent. This includes everything from fish cleaner to our blast freezer. It's a lean, efficient investment perfectly suited for cottage-scale operation in Malaysia. Our monthly operating costs are roughly 41,400 as expected. Raw salmon makes up about 74% of this cost. Despite that, our factory remains highly profitable with monthly revenue 62,192 ringgit. We are looking at the operating income of over 19,000 per month. This gives us a very healthy cushion to invest in sustainability. Now, we have decided to implement a compact wastewater treatment system while it adds 20,000 to our capex. The economy logic is clear. We generate 250 liters of wastewater daily. By treating this, we can use 60% of it for floor washing and general cleaning, saving us a modest amount on our water bill. The real financial breakthrough comes from avoided costs. In the food industry, DOE penalties for illegal discharge are significant. We have calculated an avoidance cost of 6,000 per year in potential fines and legal risk. When you combine our water saving of 16 ringgit 70 cents with our avoided risk of 500 per month and subtract our 200 operating costs, the system actually generates a net economic benefit of 360 ringgit 77 per month. In short, we aren't just spending on a filter, we are buying insurance against legal fines and creating a more scalable, green certified business model. It supports our financial viability while ensuring we are 100% compliant with Malaysian environmental standard.
So now let's talk about the economic evaluation of alternative. For the alternative, we have two options, which is alternative A and alternative B. Alternative A is about the status quo, which is do nothing. The factory continue operation without a treatment system, remaining exposed to potential environmental. For alternative B, it's about the implementation of wastewater treatment and reuse system. For this economic evaluation, the minimum attractive rate of return is set as 10%. This rate was selected based on the typical cost of capital for small and medium enterprise in Malaysia food processing industry. So now let's talk about the cash flow analysis. The first one is present worth. This is all the value to calculate the PW using this formula. Now the value for PW is RM 4,128.08 sen. So now we will calculate the annual worth. We will using this formula. The value for AW is RM 671.85 sen. So now let's calculate the future worth by using this formula. So the value for FW is RM 10,707.02 sen. The economic analysis confirmed that alternative B is superior choice. While it requires an upfront investment, the system effectively pays for itself by eliminating the high cost of environmental non-compliance and providing long-term utility saving.
First, let's look at the key data. The project initial cost is 20,000 ringgit, with an annual net profit from the 3,801.24 ringgit. That from the water saving and the avoid fine. After paying yearly running cost, the project runs after 10 years, and its salvaging value is 2,000 ringgit, which is 10% of the initial cost. IRR is discount rate that marks the project NPV equal to 0. Here's the formula. We calculate IRR is 40.8%, which is higher than our 10% mark. This means the project meeting our profit requirement. Next, let's look at the ERR. ERR is more conservative measure. We found that ERR is 13.2%, which is also higher than 10%. This confirms the project is economically sound. Finally, let's look at the payback period. The static payback period equal initial investment divided annual net benefit. So that 20,000 divided 3,801.24, showing fast capital recovery and strong risk resistance. In short, both our IRR and ERR are above the 10% requirement, and the payback period is much shorter than the project lifespan. This proves the project is